Hello everyone, my name is Tanisha Karn and today I will be presenting my app user manual for an AI model that I created based on exoplanet detection. So I would like to sincerely thank my parents and my mentor, Mr. Abhishek, for their invaluable guidance, and I also appreciate my group members, friends, and all the online resources that I received for this project. This internship has been truly an amazing learning experience for me. And a little more about me is that I currently study in grade 12 of in GEMS Modern Academy, and I'm enrolled as a student in the ISC curriculum. So, as I mentioned earlier, like during my internship with CleverEd, I developed an exoplanet detection model, which uses AI and machine learning. So this project is just a cross section between some very important fields such as data analysis, model development, and astrophysics. And I'm very grateful for the support and guidance that I received for this, and it's really been a valuable learning experience. So, a little about the app. Before I go into what the app does, I would like to give some background information. So, a transit is a phenomena that occurs when a planet or an obstacle passes between a star and an observer. So, as you can see in this diagram over here, a planet is crossing in front of the star, and the observer over here through the telescope, they can see this. Um, and obviously, they wouldn't be able to directly see the planet from that far because it's the whole thing is very far away. So, but this phenomena can be observed as a slight dim in the light emitted by the star. So this slight dimming of light can be observed as a small dip on a light versus time graph. So this light versus time graph is very important. It's known as a light curve, and many observations and derivations are done from this by astrophysicists to come to conclusions about stars and whether there are exoplanets in front of them. If the dips caused by the obstruction of the planet in front of the star is regular and periodic, then scientists can infer that there is an exoplanet in front of the star that's being observed. So obviously machine learning and deep learning techniques are very practical, like applicable in different research areas, and this is what makes it very suitable to be applied in exoplanet exploration. Using light curves obtained by the transit method, which I just mentioned before. So these dips, the study of these dips in light on the light curve is called the transit method for observing exoplanets. So this is just one application of machine learning, and I'll just show you the app. Let's get into the app. So it's a very user friendly model. You can upload the CSV of your star light curve, which will have which will be in the format of average flux versus time. So a user can upload the CSV file, and from there it can be analyzed by pressing this analyze button, and then that's how the results can be obtained. So this is just an example of a flux versus time CSV file CSV file that can be uploaded to the GUI. So you can also input multiple stars, the information of multiple stars at a time. So as you can see, this is information for 3 stars because it has 3 columns for this. And the flux, as you can see, it has the flux for different time periods. So then, as I mentioned earlier, after pressing the analyze button, you can obtain the results. And along with the results, only if only one star is given in the CSV, then it can also plot the light curve graph to the user. But if multiple are given, then it will not do that. So as you can see, this is just the output for the CSV file shown over here. As you can see, there was no exoplanet detected. Okay, now let's just... Okay, so this is just the testing data that I've copied from here. So let's just run the code in real time and see what happens.